What I want to do here is look at the forces on a pendulum, and this is often confused. So we've got a pendulum. At its maximum amplitude, which way is the net force pointing? So we've got mg and we've got tension. Now your tension only goes so far as to stop the component of mg that's in the same direction or parallel to the tension. So the mg, the tension can only cancel that component of the weight force. So we've got Ft. That leaves us with a net force like that. So that's the way the net force goes at the maximum amplitude on the pendulum. That's our net force. It's not horizontal, right? But with SHM, we only want the restoring force. So we would only use the horizontal component, which would be that component there. Now this is the problem with the SHM and pendulums, is that this little guy is changing quite a lot. As the pendulum moves, so he's now down in the middle here. We've still got our mg. No, it's longer than that, wasn't it? It was like that. The mg stays the same. We're still going to have an Ft parallel with the tension force. But what happens, and this makes things a little bit confusing, is we've now got a velocity and it's going in a circle. Therefore, we now have need of a centripetal force. So the tension in the string doesn't only need to supply the component of the weight force that's parallel with the tension. We all know that that would be mg cos theta. But it must now supply the centripetal force. So this vector gets longer. So now your net force might be going up a little bit. And again, the SHM component is the component of the net force that is going horizontal. So if we look at the forces as a pendulum swings, the net force, let's forget about the mg, let's forget about the tension force. Let's just think about the forces. At this point we said at its maximum amplitude it was pointing down. We just saw that around about the middle the net force now is smaller and up. By the time it gets to the middle it's pointing totally up. And so with a pendulum swinging, the net force is changing from pointing down like this as the pendulum swings to where it gets to the middle, it's pointing up like that. That's the net force. And the SHM is always the horizontal component back towards the middle. And if you look at it mathematically, you will find out that for small angles, the horizontal component is pretty close to being proportional to the displacement and always back towards the equilibrium. Look at this vertical one. In the middle, the net force is just pointing straight up. What's the horizontal component? 0. If the horizontal component is 0, then the restoring force at that point is 0. If the restoring force in the middle is 0, then the acceleration in the middle is 0, which is what we found. The acceleration towards the equilibrium is 0. What's the actual centripetal acceleration? Well, it's totally towards the middle. So this is where physics, you have to be very clear what you're talking about. With SHM, we're talking about the forces back towards the equilibrium. We're not talking about the net force, and we're not talking about the centripetal force.